Hello folks, this is a question about Newton's laws, non-equilibrium, where we say Fnet is equal to ma and solve the system. This question is telling me A, so we have two masses here, a string tied to a string, and there is a pulley here. Pulley is massless and frictionless, so we assume the system can move freely here, M1 and M2 system. A tells me what happens if M1 is smaller than M2. I want you folks to go by logic here. On the left, M1G, which is the weight of M1, will be pulling down towards left. So it wants to rotate the system towards left. On the right, M2G is trying to pull the system towards right. So it wants to rotate the system towards right. Since M1 is smaller, then M2 will win and system will go in this direction. And I'm going to take that to be positive because I'm going to have Fnet in this direction. So we can say the system will rotate. Clockwise. So this will be the direction, the positive direction I'm going to be taking. Notice over here, if this is the positive direction, down is positive for M2 sides, but for M1 side, up will be positive. So my positive is the direction the system is moving. It's kind of a rotational direction. Keep that in mind. That blue is for part A. I'm gonna talk about part B with the red one. It tells me what happens if M1 is larger, and I imagine and hope that you folks can see it. It will be the opposite then, right? So M1G will win this time. It will cause the system to rotate to the left. I'm going to take the left to be my positive, and the right side up positive, left side down positive. So showing what happens with B here. Part B down will be positive there, and everything will be opposite. So the red one shows what happens if we have the case of B, M1 is larger, and the blue one shows if we have M1 is smaller and what happens in that case. Just go by logic. The system will rotate left because M1G will win. In either case, to find the acceleration, we apply Fnet is equal to, I'm going to say M total times A here because we have two masses. So we'll add all the forces. And in part A, for example, our forces will be M2G minus M1G. Because we took this to be positive over here, M1 is against that, so it will be negative. This guy will be negative, this guy will be positive, and we'll have positive force minus negative force. We are adding vectors, right? And that will be equal to total mass. That's an important thing. M1 plus M2 times A. And then we'll solve for A from here. For B, everything will be inversed, but the idea will be the same. Let me also write that down. So for B, this side will be positive, so M1G will be positive for B. Again, the red color is for B and for part B. And M2G will be negative now. This will switch, and that's all. So we will have now M1G minus M2G equals M1 plus M2 times A, and we'll solve for A from there. Notice that I ignore the tension force here, because in either case, when I'm considering the whole system, they cancel. Tension is up here. For part A, for example, tension is up here, so it's positive because negative, sorry, it's negative not positive. Down is negative here. Down is positive here. This is negative. On the left, tension is also up, but on the left, up is positive. So I have tension in two directions, one positive, one negative. I could add it to here, and they will cancel, T minus T. The same will happen here. So when I'm considering the whole system, I don't include T because of that. I just look at the masses. But then if I'm asked to solve for T, what I want to do is separate M1 and M2 systems. They're kind of two small systems separately, so I cut it from here. And I solve for the systems. For A, for example, I'm going to put for blue here. Up was positive for M1, remember? And down was positive for M2 because the system is going in this fashion, right? Then I'm going to give the signs for my forces. Weight 1 will be negative, tension 1 will be positive, weight 2 will be positive, and tension in here, tension 2 will be negative. Tension 1 and tension 2 are the same. The same rope always has the same tension. Then you apply Fnet is equal MA to them separately. Fnet 1 is equal to M1A, Fnet 2 is equal to M2A to solve for tension if you're asked to solve for. Either one you can use to solve for the tension. And the A, value of A will be the same as the value we calculated here. The same goes for B. Again, only it will be different. I'm going to take this into red. Bubble because I forgot to write it in red, but this is for part B. Alright, next question. This will be on the very hard end question if I ask you. Here we have block 1 with mass 8 kilograms. I'm going to write it over here. M1 is equal to 8 kilogram. And moving in on an incline with a 30 degree. So I'm going to call that theta. It's on the picture as well. They are giving me a nice picture here. They are nice that way sometimes. And there's another block tied to the system with a pulley, and that block is M2 and it's 22 kilograms. I'm gonna put it in here too. By a massless cord, so I assume strings are massless. We don't go into that much of details, and they are really small mass. Anyways, passes over a massless and frictionless pulley. We assume pulley doesn't apply any resistance to the system. It's frictionless and massless as well. A says, what is the acceleration of the system and the tension in the rope if the incline is frictionless? So friction is 0, part A. No friction case. System will be moving. We'll look at the forces. If the forces trying to rotate the system to the left, the winds will take that direction to be positive. If the forces trying to move the system to the right, winds, that will be our positive direction. So we have to find those forces. What are those forces? We have weight 2 here. That's M2G. We have weight 1 here. This is M1G. And we know always if we have an incline, that component along the incline is the weight, which is M1G in this case, times sine theta. So M1G sine theta pulls in this direction, tries to move the system to the left. So this guy will be going up and down on the incline. That will be a positive direction if M1G sine theta wins. If M2G wins, M2G tries to rotate the system in this direction, then M1 will be going up on the incline and M2 will be going down. There's no friction, so I don't have to worry about Fn, but it's always there. It's equal to always M1G cosine theta, whatever mass is on the incline, weight of that times the cosine of this angle here. But no friction case. If there was friction, I would just say friction is equal to mu times n. This is n in our case, and so forth, included in the system, but in this case no friction. So we'll say, let's see the forces. Let's see what is m1 g sine theta, which is equal to 8 kilogram times 9.8 meters per second squared times sine 30. If I calculate that, I should get a value of trying to see if I did that before. Okay, I didn't do that before. Let me quickly do that. So 8 times 9.8 times sine 30. 39.2. So that's 39.2 Newton. Now I'm going to look at M2G. Obviously it's larger. I actually saw that, but I wanted to go through this for you guys. M2 is 22 kilogram times the G 9.8 meters per second squared. So it's 22 times 9.8. 215.9. So it's significantly larger than m1 g sine theta. I could also see that in this case, because I'm taking a component of m1g, and the whole m2g on the right side is affecting the system, and m1 is 8, m2 is 22, so obviously the system will go towards the direction m2g wants to move it. So I'm going to erase this now. The system, I decided that the system moves in the other direction. I erased too much. Alright. Okay, now this is my positive direction. Down is positive on the right side where I have m2, and on the incline up is positive. This is confusing you guys because it's kind of a two-dimensional system that we are looking in kind of rotational direction that changes overall, but it's easy to follow. It's the direction the system is moving, and this is the motion for my direction. If I'm going to draw a larger arrow, this is my direction of motion. So along this line I always will pick that direction to be positive, and that's what I'm doing. Then I'm going to find the acceleration of the whole system using Fnet is equal to ma, but that m will be the total m, so I have m1 plus m2 here. Tensions are nicely shown in the picture here. Opposite directions, they will cancel when I consider the whole system. But if I separate again, if I look at m2 separately, and if I look at m1 separately, it doesn't cancel anymore. So I'm going to look at these masses separately to find tension. But first I'm going to find A. That A is for the whole system, for m1 and m2 all together they are moving. So they should have the same acceleration. What is our Fnet? Since this is our positive side, now down is positive here, m2g is positive. m1g sine theta will be negative. So my Fnet will be m2g minus m1g sine theta. And that's it. T's will be plus t minus t cancel. This is t is minus here actually. Plus there, and they will cancel. That will be equal to m1 plus m2 times A. Fnet is equal to ma, right? In this case I have two masses in the system moving together, so I have to add the two masses. Now if I solve for A from here, I'll divide both sides by m1 plus m2. So my A will be equal to m1 plus m2. Sorry, let me undo that. m1g, this thing, right? m2g, sorry, minus m1g sine theta divided by m1 plus m2. If I put in all the numbers, I will get an A value of 5.88 meters per second squared. That's the acceleration. The question is also asking me what is the tension. And for that, I'm going to pick this side here. I'm just going to separate M2 and look at it separately. It's all actually done in this picture here. My M2 is here. Here I have M2G. And tension is up. That's the same tension throughout. There will be that tension here too. Another separation is here. So this is for M1 and this is for M2. The system is moving down, acceleration is down, M2G is plus, T is minus. We already decided that, right? The tension is minus here. Let's call it tension, not tension prime. So if I apply the Newton's laws to mass 2 only, I'm going to call this Fnet 2 is equal to, that will be M2A. The whole mass is just M2 now. There's no other mass in this small system I separated here. And that will give me the tension. Let's write down Fnet 2. M2G is positive minus tension is negative because the direction of A is positive here. That's equal to M2A. And I turn this around, solve for the tension. What do? I simply switch here. Normally I take T to the other side, it goes as positive. M2A to the other side, it goes as negative. So what I'm going to find is tension is equal to M2G minus M2A. I got A from here, I'll enter it, and I already know M2 and I already know G, so I'm going to find my tension using those values. Once you put in all those values, you're going to find 86.24 Newton. Alright, that's again in the hardest part of questions you might get. Hardest end. Part B tells me what is the acceleration of the system and the tension in the rope if the kinetic friction constant between the incline and the block is 0.2. Now there is friction, so I'm going to add that friction. As the system will try to go in this direction, friction will be against that. So here is our friction. We already decided that M2G is way larger. Even with the friction, it will move the system in this direction. We can go ahead and check this, but mostly the questions either gives us the direction of motion or it makes it obvious that it will move in this direction. So although there will be some kinetic friction against the motion here, again this is our direction of motion. Throughout we use this direction. Friction will be in this direction. We already had M1G sine theta, and we'll apply Fnet is equal to MA. M2G here still. We'll find the acceleration using the same idea. Fnet is equal to MA. I hope that you guys can see that now net force has changed, so A will change, and M again here is the M total. What we have now, since we have this direction to be positive here, both not positive, both M1G sine theta that pulls the system to this direction and F friction will be negative and M2G will be positive, and T's will still cancel because they're in the opposite direction. So I'm going to write down m2g minus m1g sine theta minus F kinetic is equal m1 plus m2 times A in this case. We already know these two guys, right? We're going to find the friction, insert it in there, and solve for A. A, when I divide both sides by m1 plus m2, will be A will be equal to m2g minus m1g sine theta minus F kinetic divided by m1 plus m2, and I'm going to find out F kinetic. Let me put it aside here, maybe with a red. As always, right, as always, it's equal to mu kinetic times n. Find that, insert it in here, and n, which is shown as Fn here, n is always equal to m1g cosine theta. Insert those, solve for A. And our A from this one will be, as we get smaller because we are deducing one more force, friction is decreasing it further, so it will be slightly smaller, 5.48 meters per second squared. So it was 5.88 meters per second squared. Now it's 5.48, slightly smaller. Tension will also be slightly smaller. We're not going to go ahead and calculate it. But in the same way you can calculate the tension. So for mass 2, I'm taking mass 2 again because it's easier, just two forces. If I go for mass 1 here, and now I also have friction, it's going to be harder and longer, but it'll be the same result anyways. For mass 2, we'll say m2a, which is the net force, is equal to m2g minus tension. The same thing, tension will be equal to m2g minus m2a. Only this time you're going to insert the new a. Alright, go ahead and solve that yourself. We have looked at several questions about the elevators, but I want to still review this. This is quite confusing. I understand that, but if you apply Fnet is equal ma, find your direction of acceleration, take that as positive, apply Fnet equal ma, you will never make any errors with the elevator questions. So there is what we call apparent weight in an elevator, which is always the normal force. The weight we feel, the force we feel, is the normal force, and that's our apparent weight. So we always have our weight down, which is equal to mg. In this picture here, it's given as 700 newtons, so let's just put it here. And we'll show normal force, and we'll apply Fnet is equal ma. That's it. To solve for the apparent weight, and n is the apparent weight. We'll look at different situations. For example, if the elevator accelerating upward, I right away stop and say, okay, upward is positive then, because A is upward, and Fnet should be upward because it's equal to ma. A is upward, Fnet is upward. So up is positive. Then I show my forces. Weight is already shown on the person, but I'm gonna show it on again on the scale here. Weight, that's mg. That's equal to 700 newton here. There will be a normal force upward. If up is positive, my normal force is positive here. Mg is negative. So my Fnet is equal to n minus m G, and that's equal to MA. You can also solve for the N here, and it will be equal to MA plus MG. Simply take negative to the other side as positive, or add mg to both sides. 700 Newton corresponds to about mass of 70 kilogram approximately. Let's say acceleration is equal to 2 meters per second squared. We can actually solve for that, and will be equal to 70 kilogram times 2 meters per second squared plus mg is about 700 Newton. We'll just take that, and we'll see that that's about 840 Newton. Now, as we see, N here, normal force is larger than mg. And keep in mind, folks, if we have a moving system with an acceleration upward, that is the positive direction, and the forces upward will be larger than forces downward. You know why? Because I should have an Fnet upward, and when I add up all the forces, the total force should be upward then. So upward forces, when they all added up, in this case it's only normal force, it could be more different type of forces upward, they will be larger than downward forces in the case that I have an upward acceleration. These are the ideas for acceleration questions and elevator questions. Here, elevator is going down with an acceleration A. Now this is my positive direction because I must have an Fnet downward. That's MA. And weight is downward, normal force is upward. Now, let me show weight here as well. It's on the person, of course, but 700 Newton. And I say, okay, now N is negative because it's opposite to acceleration. Mg is positive, and apply the same. Fnet is equal to Ma. What is my Fnet? Now Mg minus N. And that's equal to Ma. And I solve for N. It will be Mg minus Ma. And I can input the numbers and solve for this again. If my acceleration is equal to G, we looked at it in a different context of orbiting. But it's equivalent, so we went back to this already. But if my A is equal to G, it's a free fall, and if I apply, the situation will be the same. A is down, down is positive, right? N is up, so that's negative, and weight is down, so that's positive, and I'm going to get the same when I apply Fnet is equal to Ma, right? The same as on the left. So my N will be still Mg minus Ma, and when I insert G here, A is equal to G, I'll have N is equal to 0. That means I have 0 apparent weight. So apparently I am weightless. Apparently, not really. Alright, these were some questions for you. Practice and you'll be doing good with the Newton's laws.